And we're live. Today was an interview with two book authors. Alex and Ferenc have written this book, Debunking C Myths, and we're probably going to take a look at the book later. But now, for the start, let's do a quick introduction. What's your background and what do you do with C++?
Right. So I started my career with C++ around 2000. I've done about 7 years of C++ back then. And then I moved to other programming languages and to jobs more like training, consultancy, coaching. And in doing that, my C++ knowledge has helped a lot because what I mostly do is things around software, various techniques like test-driven development, software design, software architecture, and inevitably, I work also with C++ teams. And I am connected to the community. We also organized the CPP Europe conference in Bucharest for a number of years. And I am connected to the community, but I'm not, let's say, fully writing professional C++ code right now, which is why I really needed the help of Ferenc for this book. So.
Yes, so me, I started C++ around 1998, just before the first standard came out, because Turbo Pascal became a bit obsolete those days. This was in high school. Then I moved on to university. We have had some C++ there, but I continued to use it for my projects. After university, I became a Java programmer actually, because that is what was given a salary. So for 3 years, I programmed in Java mostly. After that, I turned back to C++ while I was working at a big company in Cyprus. And since then, this was around 2004, 4, 5, something like this. Since then, I'm mostly C++. I complement it with some Python from time to time, and recently with Golang a lot, because we have a product that requires Golang. From other points of view, I write articles for various journals. For example, I had a series of Linux share programming for the Linux Format magazine. Before that, I was writing for Overload, the ACCU journal. And before that, I things on the internet, nothing significant.
That's interesting. Let's have a quick view into the book. And I wonder what's the audience this book is meant for?
Well, I think there's one audience that Pact was looking for, which was various developers. From my mind, the audience is general because the way I see things, C++ programmers are very various. There are multiple sub-communities within this big community. And there are people who are very pragmatical. They just want to write code. There are people who are very, let's say, rule-oriented. They will quote every rule from undefined behavior, the cases that can appear. There are people who are very focused on performance and so on. And the way I see this book is taking various statements related to C++ and looking around them, kind of trying to bring arguments for various views, and then giving a potential answer. But the most interesting part, I think, for readers is the exploration, is going through the journey with us and making the decisions for themselves. Is this something that, are we right? Are we not right? Kind of like that. So that's how I see it. For me, it's a general audience of C++ programmers. Of course, some people who are more advanced will find some of the chapters more interesting. People who are more beginners will find other chapters more interesting.
I actually agree with Alex on this point, that there are a lot of areas covered in C++ in this tiny book. I've got feedbacks from people that really liked that we were not staying on mainstream C++, no standard, no ranges, no concepts, no blah blah. That we were exploring those corners which are not always in front of you when it comes about C++. For example, how does your program start? C++ actually does not care about this. These are tiny operating system specific details that are, in our opinion, important for the readers to know. Or the non-standard C++. In my opinion, the compiler writers are the most clever programmers on the planet. Sorry if I offend anyone with this. But the fact that they have implemented some features which are non-standard C++, but still in the compilers that we are using every day, means that there should be a good use for those features. So this is what we try to explore in this book.
So one thing I particularly find interesting with the book is that, I guess it's a bit bigger here, you actually quite early go into testing, and most code examples actually contain a test case. And if I want to criticize one thing in other books, it's often that testing is either an afterthought or it's not even mentioned. And I really like that in your book. That aside that from being very unique on the topics and stuff you cover, which is not like the mainstay of the other authors often, that you do have this focus on testing.
Well, thank
which
you.
Stays without being like the topic of the book, right? So that's like one thing I really want to point out. Which brings me to my next question, what standards and what standard do you cover in the book? It's not specific about one standard, so.
It's not specific about one standard, and I think it's a bit hard to say because part of it are about modern C++, part of it are about these corners that are kind of weird sometimes. What I try to do, so basically the book is we split the chapters between ourselves because it was the easiest thing to do. So at least in my chapters, I tried to use G++, mostly G++ for 20, C++ 20, what's 4 or something like that. But honestly, it's not focused on one specific standard.
Here I agree with Alex too. We did not have a specific goal to cover C++ 20, 17 or whatnot. We wanted to write about C++ itself. Actually, there is a lot more focus on non-standard C++ in one of the chapters than on any other standard that we have.
So what did you learn about C++ while writing the book?
Personally, I learned about a lot of tools that can be used for memory, for finding memory errors. And I think not only. These were when I was doing the research for the memory safety chapter, this was one of the things I learned, and also other various tools, because our reviewers also suggested some. Ferenc taught me about some of these tools, and this is mostly what I got.
I've learned about the corner cases of C++ that are not everyday code and code that you should not write, but it's still fun. For example, the C++ is beautiful chapter that has a lot of unconventional things you won't find anywhere. So I think my biggest learning phase was in that chapter.
Mm-hmm. Do you follow the C++ standardization?
Yes, definitely. We have to, otherwise we'll just stay behind and be forgotten like the dinosaurs. And I really like the direction the C++ is going in the last 10, 15 years. Before that, there were a huge amount of material how to write safe C++ code. Recently, I have not found any book like that. So in my personal opinion, this is something that modern C++ has fixed. It includes a lot of other mayhem too, but most memory safety issues and other dangerous corners were fixed in the modern C++ from 11 onwards.
Yeah, I'm also following the C++ standardization, but more from afar, and I'm more interested kind of in the big things, like what it's doing for memory safety right now, or so not so much in specific details on how syntax changes and stuff like that.
Yeah, I think that lots of the things which are now coming with C++ 26, which are interesting, will also require lots of time to be implemented. And with modules, that's like still like it's a 20 feature and it's now 5 years and it's becoming available, but still a lot of adventure to be had with modules. There actually is an audience question. Nikita Kanchan asks, can you name some of those tools used for memory leak detection and errors?
Yes, if you work on Linux, there is Valgrind, so that is the basic tool you get for this. And something I have no idea about is recent and decent for Windows. 20 years ago, there was some proprietary tools for Windows, but now, sorry, I'm on Linux for the last 15 years.
Yeah, I think we use Valgrind in the examples in the book. I've also learned about a few other interesting tools, mostly related with package management, although I'm really curious how many people actually use package management in C++ outside large companies. I think in large companies, it's probably they have teams who deal with this, but otherwise, it doesn't seem that easy to work with.
Yeah, the statistics I've seen on this is like 40% currently. I've posted yesterday from the survey which Mini C++ runs. One of those was on package management.
Yeah.
So both Conan and VC package are now above 20% usage. And regarding the memory leak and errors, I think the sanitizers are now really mature and should be used. And actually, it's something I've seen yesterday also. I've clicked through the whole survey yesterday, so I see that sanitizer usage also has become a lot more in the recent years. And there's a memory sanitizer, there's a threat sanitizer, there's an undefined behavior sanitizer, which tremendously will help you with your code quality.
Yeah, cool.
Which brings me to, like, I know when you write books, it gets complicated and complex, and not every error is being catched in the review process. So what are the things that came up with your book since publication, which you might want to fix in a second version?
Well, so how long did it take? I think 1 month or so before an astute reader caught an undefined behavior in one of our examples. And to me, that's great because it shows the engagement with the book, and it's it's a really good thing. Now, of course, we don't want to make these mistakes, but seeing people getting engaged so much, it's good to see.
Yes, I really like that error actually that we put in the book, that undefined behavior for const objects. If you cast away the constness, you don't know what will happen. I tried the code on Bolboaca, and for normal const objects, the code works. But for static global objects, yeah, obviously it crashes because it goes in the read-only memory. But as a side note, when these techniques were necessary, that the mutable keyboard was not in the compilers, most of the platforms did not have this kind of protection for memory. So there you could basically do everything. In DOS, you can jump wherever you want, you can write code wherever you want. So these errors were not caught in those days. Now, with Linux and Windows, things are a bit more safe and secure.
All right. I think one hot topic nowadays is always AI. And so what's your personal experience and opinion on the whole rise of usage of AI and coding?
I've been following AI because you can imagine from my kind of work, it's very interesting to see the trends. And first, the way I use AI is more like a junior researcher. I'm asking questions, but I'm assuming it will be wrong, and I have to double check. That's my general approach. And in terms of coding, I think, well, the general problem with large language models is that they hallucinate, which is actually the way they work. So it's wrong to say that they don't, that it's a mistake. No, this is exactly the way of working. That's what they are supposed to do. And because of this, they will generate things that are not correct. Now, one way to fix this is to go into a smaller context. So from my experience, if you go into a very specific context, like for example, REST API, and you tell them, give me a REST API for that thing, it will give you something that resembles a good design. It's not always great, but it's a good start. It's something you can start from and adapt. But in general, I think one thing that I expect to happen is that this year we'll have more agents, which basically means AIs, large language models that are specialized on specific and smaller contexts. And those might replace some tasks that people are doing, mostly what, I work with many teams in organizations that just take data from one site, they move it to another site. And those types of jobs, I think, might be affected. But what will also happen is that we still need people, and we need people not only to know what to ask these models, but also to correct them and to bring the next level of design and architecture and security and whatever else. So this is where we are. I don't know exactly where things will be going because they are still in flux. I don't think we'll get AGI in the next 5 years. But I think we'll get more specialized agents that can do some of the specific jobs. And because of these people who are really good at what they do, they can be more leveraged. I mean, you can work with a group of agents that do some of the work for you and you just correct and adapt and so on. But I don't have a crystal ball. That's just an opinion based on what I've seen.
The way I see AI is that if someone somewhere on this planet has written the code for the specific question you have, then it will give you a good answer. For very simple tasks, writing a program which will sum up the numbers till 1000, it will give you a correct answer. If you ask something more specific, it might invent libraries and headers and classes which don't exist yet. So we try to ask him to write interpreter for a very specific chart format we are working with. It invented no problems, all the classes, all the headers. It showed the code, but it was just put your code here in the implementation part. So it helps, but it does not do your job yet. I'm not afraid.
Mm-hmm. I think that we are now basically also going to be able to see the effects on our own code bases, because it's not just something which has become available, it's something that has been used. And this morning I've just seen something in this direction, and let me quickly share this with you. Here you see that the code quality seems to go more up into direction of being copy-paste in code bases, and you clearly see that this is an effect going on. And I find that like this is seems to be a blog or a company which also is here directly. It's on GitHub, so it's like AI on CodePilot code quality, and they say it's like in the last 24 months, last 12 months, you clearly see this influence and change in things and patterns we've had. And I think it's quite interesting, and this only will continue, right? The other thing I think, is AI able to teach you if it's just able to, make up things? And so where are we, experienced C++ developers and experienced devs in general who know patterns and design might be the ones who have that knowledge, and that will probably become very valuable to a lot of companies, because how is a younger generation going to learn when it's more or less getting used to just copy pasting and asking the AI? So I think for boilerplate code, it's very good to do prototypes. It's very good, but to actually clean up, refactor, and to do useful testing, that's probably different. But we've been talking about C++ myths, and there's actually two myths where Andrei Zissou asks about C++ is slower than C, and C++ is unadvised for embedded platforms. Are these still like myths which are widespread? And
the first question is slower than C. Depends what you want to do with it. In C++, you can write C code, and that highly possibly will end up at the same speed as standard C code. However, for very specific scenarios, which pretty much depend on C++ moderner features, like lambdas and modules and standard template algorithms of the heavier type, I think it will be slower than if you write a plain for loop and do your pointer magic. But it will be much more readable. What is really much slower in C++ is the compilation time. The C code is very plain, very simple, very straightforward. It's ugly, but compiled faster. C++, much more readable, much more detailed, much more modular, compiled slow. Alex, will you take the other one?
Yeah, I'm not that, to be honest, I'm not that sure about this. I work with teams who are doing C++ for embedded systems, but in a recent promotional event for the same book, somebody from Google told us that they switched for Google Pixel, I think, the bootloader to be in Rust. So I don't know where these things are. I know people who are doing embedded C++, but apparently there are also people using Rust or other technologies. I mean, being unadvised depends. You need to be careful about security, and that's probably it.
Yeah. I think it's easier to write slower C++ than C, because you can easily make a lot of copies in C++, which will make you slower if those, don't be taken out by the compiler due to the longer compilation times. And I do think that all of those two myths are actually like overcome, and there's a MISRA standard for C++ and embedded, which is followed in a lot of companies, and I see that also being the reason that a lot of like the automotive, even in Germany, is still on 17, because that's what the standard says, and that's what then that's what you have to abide to. There's not choices to bring in code which doesn't pass the sanitizers and the checkers in this world. But you've mentioned Rust in this context, and there's actually a chapter in the book on this. So let's quickly have a word on the popular topic about, Rust and C++.
Well, that was one of the chapters I wrote, and it gave me an opportunity to play around more with Rust than I did before. It was very interesting. And honestly, I like Rust personally. It's the kind of language, if I wanted to do more systems programming, that looks a lot like the combination between simplicity but also control, kind of. I think it strikes a balance there. But I think it's very hard for C++ to go away, because there's so much C++ code, and because that code also implies a number of other things like tool set, people who know that code, and so on. So basically what I did in this chapter, after I went through all the things that Rust is doing, the things that C++ is doing, where they compare, in various areas, I ended up saying that Rust might replace C++, but if 4 things happen, and I'm going to give you one spoiler. One of them is if we will have, since we're talking about AI, if we will have AI systems capable of translating from one programming language to another. because I think this is a potential use case for LLMs. And if that happens, at least there's a chance that you might need to, you might be able to translate some of the existing C++ code into other technologies, and one of them being Rust. I also think that the C++ community is still very large, very active. There are a lot of tools, a lot of things, and that's very difficult to replace. So beyond the technical aspects themselves, the social aspects are also important. And yeah, so that's kind of where I land on it. But it's very hard to predict what might happen.
Yes, I agree with you. What my thoughts are about this issue is that there will be fewer and fewer new C++ projects, more and more new Rust projects, and more transition of older C++ code base to newer standards. That's what I think is a more or less possible scenario that will come up. Rust is not really a replacement for C++, in my opinion, but it does a good work in trying to be.
Yeah, I have high doubts about Rust being the language to completely replace the whole body of work we have with C++, which is huge. And the required financial investment for any organization to do this switch is so big and so risky also that I have my doubts that that will happen anytime soon. And so I do think that Rust is an interesting opportunity for bootloaders, for safety critical things. And what I found very interesting, we did an interview with a keynote speaker last year who works for Adobe, Titus Winters, and he's on the one of those teams planning in which ways they have to use to transition from which parts of their infrastructure they have to transition into memory safe languages. And I think that's one of the big answers which C++ has to find is in which ways can we make C++ memory safe. And I don't think that this is something you can do as a standard, because then you need to make this something which is needing to be implemented in various ways, and you have the whole issues taking forever. You need to have some tooling for that, which is maybe some add-on to Misra, etc. But then the whole other question is this also has been an artifact of the Biden administration, and this might just be look very different now due to the cost artifact and to the investment needed into this that might not be as important anymore. And that's something that we will see in the next months, I think, if this is in which direction this goes. And regarding C++, how does this book help you to write better C++ code?
Yeah, so I think there are two ways, at least from my perspective. I work mostly with two types of programmers. I work with advanced programmers who already know C++, and what we are working on is more of a change in mindset. And for them, I think the most beneficial parts of the book is expanding their horizon. For example, there's a chapter on various paradigms you can use when writing C++ code. And in a large program, you can use these paradigms in different modules, because each module will fit different types of different needs, different technical needs. It's also showing that, from my perspective, C++ has multiple dialects, and different teams are using different dialects, different subsets of the language. So seeing other subsets after you've done, I don't know, 10 years in a specific subset is something that is really useful, expanding your mind, knowing that those exist and maybe taking bits and pieces or figuring out that a specific paradigm actually works better for a part of your code. And the other types of programmers are people who are just starting to learn C++ or any programming language, but in this case, C++. And for those, there's a specific chapter on learning, and I think that's really useful. I'm very passionate about helping people learn better, faster, and some programmers reached out to me that I want to learn a programming language. How could I do that? And part of the advice is there. But in general, taking various statements about C++, looking around those, it's a good conversation topic in your organization. It's a good thing to expand your mind and to try out perhaps slightly different approaches for your code.
I actually agree with Alex. I would just like to add one more idea that some parts of the book show the extreme possibilities you can have with C++, and then specifically tell you do not write code like this. We have to admit that high quality code is boring. It's readable, it's beautiful, and boring. Because that is what people understand, that's what they can read, that is what they can maintain in 20 years from now on. The extreme C++, that is good for fun, but avoid it in a project.
Yeah, especially Alex, like speaking about culture, it reminds me of a post I've done. Like one of my first blog posts on meeting C++, which I did, was about islands of C++. How the community has been very fractured, and part of this has been moving forward in the last 10 years. But basically, it's still the case that there is every company is kind of having their own culture. And when I worked as a freelancer, I saw that it's like everywhere it's different. And a lot of people back then didn't do testing, but they had like some approach to testing. But then they maybe had some testers which did testing, but unit tests were still like a very new thing back then. And I think that part of those, like the sea between those islands, has been kind of filled in, and we have transitioned into the central parts of the language, like templates being more mature. I can remember that like Qt at its core does not use templates a lot. WX Widgets had in its wiki a page on templates and making people careful and telling people that not every compiler is supporting stuff in that. And now we have a world where you basically are able to write your code in constant expression if you can keep up with the tooling and the newer versions of the standard, and make your code very much immune to undefined behavior and a lot of other things. And of course, this will have you a bit more compilation time. But I think it's very interesting things which we've seen in the last 10 years. And your book is like, I think one fair thing which one should say about your book, there's no big story arc. You really can like pick out various chapters and read them.
Yeah, it's like a book of essays, basically, taking a statement and looking at it from various perspectives. And you can pick whichever one you find interesting first and then go through the others if you feel like it.
Yeah, that was the main idea. Just pick it up, open it somewhere, read something fun, close it. Next.
Yeah. So how did the order of the chapters come together? are they like random, like the way you wrote them, or did you do like some ordering when the book was done?
Initially, we had 32 chapters, but the folks at PAX told us it will be a bit too long. Then we ended up with 12, and there was no real order, if I recall correctly.
No, I think we set the order.
Yeah.
And
No specific.
yeah. And then we split the chapters between ourselves.
Hmm.
And that's and that was it.
When you had 32 chapters, will you like have a part 2 of this book with more chapters that in the
Well,
works?
I guess if this one sells well, then we'll be asked to write the second part. Yeah.
Yes. That would be fun, actually.
Yeah.
Yes. Okay. So I see there's like no more audience questions, and we're now at like 40 minutes. I think that's also long enough for an interview. So thank you for your time. We're all waiting for lunch. So final thoughts.
Thanks a lot.
You're welcome.
Thank you for having us, and yeah, great to be with everyone.
Yes.